Today on How It's Made. Aluminum pots and pans, artificial limbs, peanut butter, and the high-intensity light bulb. There are several different ways to manufacture aluminum pots and pans. Some factories have giant machines that simply stamp out or mold the cookware, while other factories use a technique called metal spinning.
To make cookware that's safe for food use, the aluminium must be pure, with no other metals mixed in. It all starts with a round aluminium sheet called a blank, where the pot size and company name are stamped onto what will be the bottom of the pot. The blank is clamped onto a lathe and centred against what's called the chuck, a metal mould shaped like the inside of the desired pot. The lathe spins at 2,000 revolutions per minute, whilst the spinning tool, a round wheel made of a special plastic, is guided by computer as it pushes against the chuck, stretching and shaping the aluminium blank. The machine trims off excess aluminium as it rounds the edges. As aluminium is very expensive, the shavings are sent off to be recycled into other products. After the final trim to size, another lathe moves in to take the sharpness off the edge. It's taken 4 minutes to spin this 32-litre pot. Handle holes are then punched out. Then aluminium handles are riveted on. This pot is now finished. Items that aren't as large and heavy are spun on the lathe. An experienced metal spinner is needed because this trade isn't mechanical science, you've got to have a feel for it. Besides cookware, many other aluminium products are spun on a lathe. This is a light reflector, a round aluminium fixture that surrounds light bulbs in factories, shops and stadiums. When working the hand lathe, the metal spinner uses what's called a scissor tool. It's the equivalent of the plastic wheel on the automated lathe. As the blank spins, he moves the tool further and further down to stretch the aluminium into the right shape. This is a sausage funnel. And this will be the inside tube of a cake tin. The metalworker makes the body of the cake tin on a different lathe, using a variety of tools to get a variety of effects. This beading tool, for example, creates an edge. Almost all metals can be spun, though aluminium and steel are highly malleable metals and provide the best results. So next time your ratatouille burns, don't blame the cookware, just blame the chef.
Can a baking ingredient be the answer to global warming? Canadian researchers have found a way to transform harmful carbon dioxide into harmless sodium bicarbonate, baking soda. They mix CO2 with water, then force it through plastic balls treated with an enzyme from alfalfa.
Today's artificial limbs are a far cry from the clumsy appendages of yesteryear. Now they are realistic. And thanks to advances in prosthetic technology, artificial limbs function more and more like the real thing. The process starts by measuring the amputee's stump, what doctors call the residual limb. First, the circumference is measured at different points, then the diameter. The limb is protected and lubricated by a coating of petroleum jelly. It's then immersed in algin, a gelatin-like substance that comes from algae. Begun to. A couple of hours later, it's stiff enough to be used as a negative mould. Plaster of Paris is poured in, then a metal rod is inserted. The rod will be used to mount the dried plaster, allowing specialists to work on it. It takes about an hour and a half to harden, then the algin is dispensed with. Then, using sandpaper and files, the surfaces are refined and smoothed. This plaster copy of the residual limb will now be used as a positive mould to cast the artificial limb. There are other ways to create positive moulds. A negative mould is first built using strips of plasticized cloth, much the same way they make a plaster cast when you break your leg. Then a scanner takes a detailed three-dimensional reading and programs it into a computer. A technician then makes any necessary modifications. A plaster block is then placed on a cutting machine. And the computer guides the blade to carve out the positive mould. After either technique, once the positive mould is ready, the artificial limb can be created using a process. First, the mould is covered with fabric socks, some made of nylon, others of a material that contains fiberglass. 6 to 10 socks are used, depending on how rigid they want the artificial limb to be. Then the socks are coated with a liquid resin made of either polyester or acrylic. Here they're using acrylic, tinted to look like Caucasian skin. It's important to ensure the surface is evenly soaked. It's a meticulous process that takes about an hour. The acrylic solidifies in an hour. Polyester takes about 12. Then the plaster mould is broken, leaving a durable plastic shell, called a socket. That will be the basis of the artificial limb. The socket connects to another plastic shell containing the mechanics. Or, like this artificial leg, the mechanism can be modular and covered in just a skin-coloured foam. If the muscle at the site of the amputation still emits a good electrical signal when contracted, the patient can get a myoelectric prosthesis. It has an electrode that captures and amplifies the signal, triggering the artificial hand to open and close.